Hello everyone, welcome to another video lecture of Mathematics Solution channel, and today we are going to discuss about Fourier transform. So before getting to solve Fourier transform problem or Fourier transform derivation or whatever it is, we must know what is meant by transform, right? And why it is important. Well, transform is a mapping from, it may be one set to another set or one domain to another domain. For example, if you take the signal, it is normally denoted as a time domain, but we need it is in the frequency domain. For that, we need to convert time domain to frequency domain, we need some transformation. Well, and most of the physical problems are expressed in terms of sine and cosine transform, and obviously the Fourier transform also can be written as in terms of sine and cosine functions. Well, the Fourier transform can be classified into two types by the nature of the function. So one is Fourier cosine transform and another one is called Fourier sine transform. Let us take what is the nature of that. Already we discussed in the previous problem that nature of the function may be odd function or an even function. Suppose I have the function f of x is a piecewise continuous and also absolutely integrable in the x belongs to set of real numbers or in the real line. Then in the nature of that function, first I am going to consider if f of x is an even function. F of x is even function. We all know that the sine integral and cosine integral formula. By using that, I can write f of x is equal to integral 0 to infinity, right, a of omega or a w. Sometimes they may use a lambda like that, okay, cos omega x into d omega. We know what is a omega here, where a omega is equal to 2 by pi integral 0 to infinity f of x cos omega x into dx. So this is the a omega here. So here I am going to do slight modification here, that is the 2 by pi can be written as 2 by pi and 2 by pi. If you multiply root 2 and root 2, the root will get cancelled, you will get the original value, that is 2 by pi integral 0 to infinity f of x cos omega x into dx. So in this value I am going to consider some fc of omega, right, or you can take capital F also. So fc of f means the function, c means it is a cosine, it represents cosine, right? So this fc of omega is equal to root of 2 by pi integral 0 to infinity f of x cos omega x into dx. If let us take this is number 1 and this is number 2. Now substitute fc of omega, right? What is the fc of omega here? That is root of 2 by pi 0 to infinity f of x cos omega x into dx. Substitute here, what you will get? A omega will become, that is a of w will become root of 2 by pi, then fc of omega or fc of w. So this is the a w value. Substitute here in this function, that is f of x will become root of 2 by pi integral 0 to infinity cos omega x into d omega, correct? Sorry, a w into a of omega into cos omega x into d omega. Let us take equation number 3. Now the second equation is called Fourier cosine transform, and the third equation is called inverse Fourier cosine transform. Okay, the second equation is called Fourier cosine transform, and the third equation is called inverse Fourier cosine transform. So this is for the function if is an even function. Suppose if the function is f of x is odd function, okay, f of x is odd function, as usual by just recall the Fourier Sine integral. So what is that? F of x is equal to integral 0 to infinity sine omega x into b of omega, or you can write b of omega into sine omega x into d omega. What is the b of omega here? B omega is equal to 2 by pi integral 0 to infinity f of x sine omega x into dx. As usual, I am going to rewrite this 2 by pi as a root of 2 by pi and another root of 2 by pi. So what we will get? Root of 2 by pi and another one root of 2 by pi integral 0 to infinity f of x sine omega x into dx. So this is a b of omega, correct? And now this value I am going to take f s of omega, or you can take capital F also, right? The Fourier sine transform. And if you substitute this b omega in this equation, let us take equation number 4, right? If you substitute b omega value, and this fourth equation will become inverse Fourier sine transform. How to substitute here? So this term, so f s of omega is equal to root of 2 by pi integral 0 to infinity f of x sine omega x into dx. Let us take equation number 5. Okay, now substitute fifth equation. In this value, if you substitute that, you will get root of 2 by 5 into fs of omega. And now I am going to directly substitute fifth equation in the third one, what's our fourth one. So you will get f of x is equal to root of 2 by pi integral 0 to infinity, right? F s of omega into sine omega x into d omega. Let us take equation number 6. Now the fifth equation is called, equation 5 is called Fourier sine integral, sine transform. Okay, and sixth equation is inverse Fourier sine transform. So what is the transform here? The function x, right, is transformed into w. The function is x is transformed into w, right? That is, x is the function, inverse function, right? F of x is equal to root of 2 by pi 0 to infinity fs of w sine omega x into dw, or omega, just leave it. So this x is transformed into omega. So this is the transformation. Here we got two types of transformation. One is Fourier cosine transform and another one is Fourier sine transform. These are all depends on the nature of the given function. So if the function is even, you will get Fourier cosine transform. If the function is odd function, you will get the Fourier sine transform. So this is how we can derive the Fourier cosine and sine transform. And thanks for watching.